All right, final thing we're going to go through is here on page 3. We've got two questions that are kind of backwards of what we've been doing, where I'm not going to ask you to find the average. I'm going to actually ask you to find a data point that's going to make an average happen. So we're going to look at this first question. Martin knows that he earned a 92 on his second test, a 94 on his third, an 83 on his fourth, and an 87 on his fifth test. He can't remember what he earned on his first, but his teacher just told him that he has a 90% average. Determine what he answered on the first test. So, here's the thing about how we would find the average. We would take his first test, but we don't know what he got on his first test, so we're going to call that X. And then we would add that to the second test. We would add that to the third test, to the fourth test, and to the fifth test. And we would divide by how many things we're adding together, which is 1, 2, 3, 4, 5, and that would normally tell us our average. But in this case, we don't know what that first test is, but we do know what the average is. Our average is a 90%. So we know whatever that value for X is, when we plug it in, that's got to simplify to 90. So how do you solve an equation that looks like this? Well, you look at where X is. Looks like we got to get rid of some numbers around X. What's going to make this a little bit easier to do, folks, is if we combine all of the numbers 92, 94, 83, and 87 first. If you add up those four numbers, I'm getting 356. I'm hoping I'm not making a mistake. And this hopefully looks a little bit more familiar in how we solve something. So we look at the X. It's got, it's being added to 356, and then afterwards it's being divided by 5. So the first thing we're going to do is, since everything is being divided by 5, we're going to multiply by 5 to cancel that denominator. 90 times 5 is 450. And then our final step is to subtract 356, giving us that Martin scored a 94 on his first test. So that's how we do these problems. We're a little bit backwards, where instead of knowing all the data points, we have a missing data points, but knowing the average, we're able to figure out what that data point was. All right, the last problem is a little bit different than that, where I'm going to tell you the average of some parts, and we're going to figure out how to do that to find an average over a total more. So, the VHHS water polo team averaged 6 goals in their first 3 games, 15 goals in their next 5. How many goals do they need to average over their next 4 to have a total average of 10 goals over those 12 games? So how does a problem like this work? This can get a little tricky. We can't necessarily say exactly how many goals they scored in the first 3 games, but we know that if in the first 3 games we were to add up those 3 goal numbers and divide by 3 the number that we have, we know that their average was 6. If we think about the next 5 games, their average was 15 goals. Well, I don't know exactly what each of those 5 numbers is. Let's see if I know my alphabet here. But I know if I were to add them all up and then divide by 5, we do get 15. So here's the thing about this. We can think about each of these scores, as even though we don't know specifically what they are, we know that they average to this number, and we can consider them to just be that value. Even if they scored 5, 6, and 7 in the first 3 games, that's going to give us the same result as if they just scored 6 in each of the games. If they scored 1, 6, and, I gotta do this right, 11, even if we add up those 3 and we divide by 3, we're still gonna get 6. It doesn't matter which of these I pick. So the easiest thing to do is to think about these values as just all being the average. So if they scored 6 goals in each of their 3 games, their average would be 6. So we can think about the first 3 games as just being all 6s. And similarly for our next 5 games, I don't particularly care if they weren't exactly 15 every game. They average 15, so we can consider that if they scored 15 in every game, their average would be 15. And then we got to think to ourselves, how many do they need to average over their next 4 games? So we have 4 games in which we don't know what we need to score, but let's just say they're all going to be the same. And then we divide by how many games this is, which is 12, and we want the average to be 10. Now I'm going to write this in a slightly different way that's going to make doing these problems a little bit faster. So they averaged 6 goals over 3 games. It's the same thing as 6 times 3. They averaged 15 goals in their next 5 games. 15 times 5. What do they need to average over their next 4 games? So what, and then we'll call it an X, over their 4 games. And then if you think about my setup before this, if we multiply both sides by 12, that gets rid of the denominator. So that's got to equal 10 goals over times their 12 games. So this is another way to set up a problem like this. Makes it seem a little bit quicker to do here. And now it kind of looks more like an equation, not even something with a fraction. Makes it feel more doable. So 6 times 3 is 18. 15 times 5 is 75. X times 4, I'm just going to rewrite that as 4x. And then 10 times 12 is 120. If we add 18 and 75 together, that's 93. We can subtract 93 from both sides. I'm running out of space here. We get 4x equals, what is that? 27. We divide by 4. So what does the water polo need to average over the next 4 games? They need to average 6.75 goals over the next 4 games. So hopefully this is helpful. Your homework tonight is a Delta Math. It's just going to go over some basics. You'll get some more of these difficult questions on your homework tomorrow night on the Math Excel. Hopefully you have a good Thursday, and I'll see everybody tomorrow.